All right, this is going to start the notes for 2.2, where we are talking about the characteristics of the quadratic functions. So we're going to first start, and I kind of talked about axis of symmetry a little bit when graphing in 2.1, but we are actually going to be identifying the actual axis of symmetry now. So that is the line that divides the parabola into mirror images and passes through the vertex. So it is a vertical line. Okay, so if I come down here, you can see it in red on these pictures. Just ignore everything else. I just gave you a picture of a quadratic. And the red line is the axis of symmetry. So before we do anything else, so the rest of this we'll go over later in the notes, but go over to number 1. Now, we are just dealing with today at vertex and axis of symmetry. We will get to everything else later in the week when we do the second practice to 2.2. All right, so we need to label the vertex and the axis of symmetry as well as graph this function. All right, so let's graph it first. So we need to think of the transformations that happen. We know it's reflected upside down because it's negative and that A is greater than 1, so it's a stretch. This tells us that that vertex is not at 0, 0. It goes right 1 and up 3. These two things right here help us go ahead and identify our vertex. Okay, if I'm going right 1, that means x is 1. Okay, so this 1 inside with x is the x value, only we write the opposite sign. So instead of -1, we write +1. And this is the y value. So our vertex down here is the point 1, 3. That identifies those movements, right 1, up 3. And I can go ahead and even put that vertex on here. Okay, now you had points when we did 1, 1, or 2, 1, I'm sorry, that I said to write down, so that helps you graph these. Now, you can plot any point. You can plug points into this equation and then find what y would be and plot exact points, or you can memorize these points and know that that vertex is where I'm going to start from and plot them there. This way is just faster. Either way is okay. So anyways, we know if x is 0, y is 0 because it's x squared. If x is 1, y is 1 squared. If x is 2, y is 2 squared, which is 4. And if x is 3, y is 3 squared, which is 9. Now, I'm going to take this, whatever is multiplying that parenthesis or multiplying the x squared, I'm going to take that number and I'm going to multiply the y values by it. So 0 times -2 is just 0. So this 1 changes to a -2. 4 changes to a -8. 9 changes to a -18. All right, so I'm going to use those points that I just found, starting at this vertex. That became my 0, 0. I'm going to go right 1, down 2, since it's negative. So right 1, down 2. You also go left 1, down 2. I go right 2, down 8, and left 2, down 8. This right 3 down 18 is not going to fit, so I'm not even going to worry about that. But I can go ahead and connect my dots now. And if I were to draw my axis of symmetry, let me pick a different color here. I'll draw it in yellow. Oh, yellow is not very good. Sorry about that. But the axis goes right through the vertex, goes straight up and down. It is an x equals, because it's an equation, so my axis of symmetry is x equals 1. So you can always write the equation for axis of symmetry just by looking at your vertex. It's x equals whatever the x value is. All right, so now that you've done this, I do want you to go to the practice and just do 3, 5, and 7. Yes, I'm aware you're skipping number 1 for now. You'll come back to it later, just like you'll come back and do the rest of the problems. So now watch the second video.